So we have for example, the MLP classifier, which is a neural network that we use to do classification. There is also an algorithm called the KNN classifier. And the KNN classifier works differently from the neural network, but it also does the task of classification. The way the KNN classifier works is that when you train the KNN classifier, or you fit the KNN classifier, it constructs a KD tree, just like we used for nearest neighbor lookup. And that's actually what this KNN stands for, is K nearest neighbor, which is what the KD tree gives us. So the KNN classifier constructs a KD tree, and then when you do the fitting of it, when you train it, and then when you query it, if you give it a new point and say, what label is this? Is it a trombone or is it an oboe? The way the KNN classifier works is it goes to the KD tree, and you can tell it how many nearest neighbors to find. And usually a common number is like 3 or 5 nearest neighbors. And the KD tree will say, okay, given this new point that I've never seen before, which is my mouse position, let me find the 5 nearest neighbors in the data set that I have been trained on, that I've been fit to. And then the label that it returns will be whichever label is most represented in those nearest neighbors that it has found. So it says, okay, well, if here's a new data point I've never seen before, let me see what's around that data point. And then if it's surrounded by trombones, I'll say trombone. If it's surrounded by data points that are oboes, I'll say oboe. And if it's surrounded by slightly more trombones, then I'll say trombone. If it's surrounded by slightly more oboes, I'll say oboe. And so the label that it returns is just whatever data points are near it, whatever labels are near it. That's how the KNN classifier works. The benefit of the KNN classifier is its training process is much faster, right? Because you just make a KD tree. You don't have to watch the loss go down, see if it tweak the neural network parameters, change the hidden layers. There's no training like that involved. There's only one way to train a KNN classifier. It's just make the KD tree. So that's kind of nice. If you want to do something on the fly, like in real time, do some classification based on some real-time analysis, you don't have time to like twiddle the parameters of a neural network, a KNN classifier might be a better solution for you. The downside of the KNN classifier is that the predictions take a little bit longer, because in order to do the prediction, you need to first find where are in this case, 5 nearest neighbors. And that algorithm of finding the 5 nearest neighbors can take a little bit of time. You have to do a little more computation than is needed for the MLP classifier to do its prediction. The MLP classifier prediction is very fast. The neural network training takes longer. The prediction is very fast. The KNN classifier, the training is much faster. The prediction takes a little longer. So that's the trade-off between the two. Now on the small data sets that we're working with, the KNN classifier prediction will be plenty fast. You probably won't even notice that it takes a little longer. The other downside of the KNN classifier is that it is not as capable of learning as complex relationships between the data. So the neural network takes more computation to train. It's a little more complicated in how it works. It is able to learn more complex relationships and be more distinguishing between data points. The KNN classifier might have a little bit higher, let's call it error rate, a little bit more misclassifications, because it is not as able to learn as nuanced of differences. There's also a KNN regressor, which is very similar to the MLP regressor in what it returns. You fit it to a data set, you give it an incoming vector, and it will give you an output prediction. Because it is doing a regression, that output prediction will not be a single label. It will be some set of values in a continuous range. Again, maybe between 0 and 1. And the way that this works is that it's very similar to the KNN classifier, but once it finds its set of neighbors, it actually takes a weighted average of those neighbors to figure out what the value it returns should be. So it just says, in this case, I have 4. What are the 4 nearest neighbors? what are those values? Let me take a weighted average of those values and return that as my prediction, my regression prediction. So, and it has the similar trade-off as the KNN classifier. Faster to train, slightly longer to make predictions, not able to learn as nuanced of relationships. The last thing I'll say about it is that, you know, these are good algorithms. The KNN classifier and the KNN regressor, they're worth trying. They're not like bad and neural networks are better or cooler, and so you should use neural networks. Like, these are great algorithms. They're definitely worth trying. The strengths and weaknesses I described are strengths and weaknesses. So they're not to be discarded. They're worth exploring and playing around with.